In this problem, we have two Hermitian operators A and B. So using that fact, we have to show that AB plus BA is Hermitian and the operator AB minus BA is non-Hermitian. So we'll start with the first one. Now before doing that, let's quickly define what does it mean when we say that A and B are Hermitian operators. So that means if we have two eigenfunction given by psi m and psi n, then for the operator A, if it is Hermitian, then the integral going from negative infinity to positive infinity, psi star m, which means conjugate of the eigenfunction psi m, but the operator A cap, operator A operating on psi n dx, this is the same as saying integral negative infinity to positive infinity. We have the operator A operating on psi m, and we take the conjugate of it and then multiply it to psi n dx. This goes for operator B as well. So we have fine. So we'll start with the first one. So we have to show that AB plus BA is Hermitian. That means what we need to do, we need to prove that the integral going from negative infinity to positive infinity, the eigenfunction psi star m times we have the operator AB plus BA. So that's operating on the eigenfunction psi n dx. So this must be equals to, we have the operator AB plus BA operating on psi m. Then we take the conjugate and multiply to eigenfunction psi n dx. So this is what we need to prove. If we do that, then we can say that our operator AB plus BA is Hermitian in nature. So let's start from the left hand side. So we will be splitting this integral into two. So we have the first integral with the limits going from negative infinity to positive infinity, psi star m multiplied to the operator AB operating on psi n dx plus the integral going from negative infinity to positive infinity, psi star m. Now we have the operator BA operating on our eigenfunction psi n dx. Now let's look at the first integral. So this particular integral can be interpreted as we have the operator A. So this is operating on B psi n. So this is the same way as saying we have the integral going from negative infinity to positive infinity. We have operator A operating on psi m and we take the conjugate. That's true because we have already mentioned that operator A is Hermitian in nature. So that means we can rewrite this in particular fashion. Multiply to B psi n dx. The same goes for the second integral. So we can rewrite it as, so if we look at it, we have the operator B here, which is operating on A psi n. So this means we can rewrite it as the operator B operating on psi m. When we take the conjugate and multiply it to A psi n dx. Then again we can say that this in the second integral we have the operator B operating on psi n. Since B is Hermitian, so we can say that this is equivalent to writing as B A psi m conjugate we have multiplied to psi n dx. Same goes for the second integral. So we have operator A operating on psi n. So we can rewrite this integral as operator A operating on B psi m. So we take the conjugate of it and multiply it to psi n dx. So now that we have applied the definition, we can combine the two integrals. So we have integral going from negative infinity to positive infinity. So we have BA psi m. In the next step, we're going to simplify it. Conjugate plus AB psi m conjugate whole multiplied to psi n dx. So this particular expression can be also rewritten as, so we have B A plus AB So that is operating on the eigenfunction psi m. Then we take the conjugate of it and multiply it to psi n dx. So this is actually proved because we started out with the operator AB plus BA operating on psi n, and what we have got, we have used the definition that A and B are Hermitian, and we have obtained that the operator AB plus BA is now operating on psi m with the conjugate. So this proves that our operator AB plus BA is Hermitian. So coming to the second proof, so here we have the operator AB minus BA, and we need to show that this is non-Hermitian with the fact that A and B are Hermitian. So let's start with the definition. So we have the integral going from negative infinity to positive infinity, the eigenfunction psi star m, multiplied to, we have the operator AB minus BA. So that's operating on the eigenfunction psi n dx. Now we're going to expand this integral into two. So we have integral going from negative infinity to positive infinity, psi star m multiplied to the operator AB operating on psi n dx, minus integral going from negative infinity to positive infinity, psi star m, we have b a psi n dx, just like the previous problem. So here we have the operator A operating on b psi n, so that means we can rewrite it as integral going from negative infinity to positive infinity. So instead of A operating on b psi n, we can write it as the conjugate of A operating on psi star m, it's the same thing, times b sine n dx. Same goes for the second integral. So this can be written as, we have b conjugate operating on psi star m times a psi n dx. Now we have the operator b operating on psi n. So this will become integral negative infinity to positive infinity. So we have b star a star psi star m whole multiplied to psi n dx, minus integral going from negative infinity to positive infinity. So here we have operator A operating on psi n. So that's the same as saying operator A operating on the operator A conjugate operating on b star psi star m whole multiplied to psi n dx. Now what we can do, we can combine this to integral. So we have the integral going from negative infinity to positive infinity. We have b star a star minus a star b star operating on psi star m times psi n dx. Now here we will use the fact that since A and B are Hermitian, so that means we have b star a star, so that's equivalent to saying ba star. It's the same thing. Same goes for AB. So we have a star b star, so that will be equivalent to saying AB conjugate. Right, so let's use this. So we have integration negative infinity to positive infinity. So we have b a conjugate minus a b conjugate, whole thing operating on psi star m times psi n dx. So what we will do, we'll take negative as the common factor so that we can rewrite this expression as negative integral negative infinity to positive infinity. So we have AB conjugate minus BA conjugate, whole thing operating on psi star m times psi n dx, which is equals to negative times the integral going from negative infinity to positive infinity. So this can be also written as, we have AB minus BA, we take the conjugate of it and then we operate in on the eigenfunction psi star m times psi n dx, or simply put, this can be written as negative infinity to positive infinity. We have a negative sign here, so we have AB minus BA. So this is operating on the eigenfunction psi m, and we take the conjugate of it and multiply it to eigenfunction psi n dx. So we started out with the positive integral with limits going from negative infinity to positive infinity, psi star m times, we had AB minus BA, that's the operator which operates on psi n dx, and we say that this is the same as negative times the integral AB minus BA operating on psi m. We take the conjugate and multiply it to psi n dx. So this tells us that our operator, which is AB minus BA, so this operator is non-Hermitian. So in fact, it's actually skew Hermitian in nature. So this is a skew Hermitian operator when A and B are two Hermitian operators. Thank you.